Hello everyone. In today's video, we shall see the projectile motion. One of the important cases, what if the projectile is released at an angle lower to the horizontal? So in the series of projectile motion, we've seen the various situations wherein finding out range and to the elevated angle. This is an elevated angle. We can actually move it. And also now we are trying to find out like what if the projectile is fired at an angle lower than the horizontal. Now you can see it is 20 degrees lower to the horizontal. So now when we resolve the components like as usual, like in the previous case, if this is the projectile, we know the resolution of the vectors, right? So when this is the initial velocity and this is the angle, so this would be the horizontal component and this would be the vertical component. So this is u cos theta and this is u sin theta, correct? Now what will happen if I move the projectile lower to the horizontal somewhere here? Let's say just I am moving it at 20 degrees and I am not changing the initial velocity, which is like 18 meter per second. Okay. Now when you draw the components of the velocity, this is the velocity direction and this is the horizontal. So this is angle. So this would be the horizontal component, which is u cos theta. And this is the vertical component u sin theta. This is how we resolve the components and the rest is all same. We will be using the same equations, etc. So let me fire this with 18 meter per second. And uh, before I fire, I just want to check where it lands on the floor. We will try to figure out what is the horizontal displacement. So let us first write what is ux. Ux is equal to u cos theta. And u is 18 meter per second. And cos, the angle is 20 degrees. So 18 cos 20. When you use calculator, it would give you around 16.91 meter per second. Let us also try to find out uy, which is u sin theta, vertical component. And this is going to be 18 sine 20 degrees. When you use calculator, you would get it around like a 6.156. I'm rounded off to 6.16 meter per second. So this is uy. Now let us start doing the calculation of range, horizontal range or horizontal displacement. As you know, horizontal displacement is r, or you can just say x, which is horizontal component of velocity times time. But again, I do not know what is the time taken. So, but I know what is ux. R is equal to ux times t. So we need to figure out what is t. For that, let us take the second equation, which is y is equal to uyt plus half ayt squared. Now, what is the vertical displacement from here to here? Let's suppose this is the origin. The important thing is deciding the sign convention is important in physics, as we all know. So let's say this is, let me take black. This is the origin. The cross mark is origin. And this is positive y-axis. And this is negative y-axis. And this is positive and this is negative. First, we have to decide like which is positive and negative. And now whatever is taken in the downward direction is all taken negative, correct? So this is negative direction. So here the important part is the vertical component of velocity is taken down. So we take uy negative here. Okay. So in the same way, this is going to be the place where the object finally lands somewhere here. So final displacement is 0 and the initial position, final position is 0, initial position is 10 because it finally lands on the ground. So 0 minus 10 This is going to be uy, but as I said, it is taken negative. So negative uyt plus half ay. Again, acceleration along y direction is g. It is also acting downward, so negative g. So minus half gt squared. Now, when you substitute, negative 10 is equal to uy. We already calculated uy, which is 6.16. And the time we do not know, minus 1 by 2g, approximately 4.9 t squared. So we get one quadratic equation 4.9 t squared plus 6.160 minus 10 is equal to 0. All right. So now we solve for t using some quadratic equation or quadratic equation solver. Directly you can search in Google. When you solve this, you have one negative value and the positive value. And the negative value is obviously ignored, and positive value is 0.93 seconds. All right. So we got t now. Now, what is to be found? The range or the horizontal displacement. Now, as we know what is t, we already know ux. You can directly substitute in this. So let me erase this part. Uy I'm erasing. Now, what is the horizontal displacement? R is equal to ux times t. Now, ux is 16.91 times time. We calculated time as 0.93 seconds. So when you use calculator, 16.91 times 0.93, it's going to be 16.91 times 0.93. It is 15.7263, but I'm taking 15.7 meters, right? This is the horizontal displacement. Now this is 15.7. I'm writing here, and let's erase this. Now, when you fire this projectile at an angle 20 degrees lower to the horizontal, it lands at a distance of 15.7 meters as per the calculation. Now, let us check this with by firing it. Okay. Chalo, let's fire this. And before that, I'm moving it to 15.7 and start firing. Chalo, 3 stars. So it exactly 15.7. So which is proved to be correct. So here only thing is sign convention is important. When you fire something in this direction, u sine theta is taken positive because it is upward direction. When you are firing in this direction, the vertical component of velocity is taken negative. Only this is where we need to be careful when applying sign convention. Thank you.